All right, everyone. So welcome back to CPC 458 malware analysis. And today we will continue our discussion of basic dynamic analysis, and we will learn a few more useful tools, really cool tools if you ask me. And then we're going to be using them in order to analyze some real malware. All right. And this will involve putting our VM up online. So before we get started, just a quick little review here. So in the last class, we talked about the limitations of the static analysis. So the static analysis is when we look at the malware and we study what the malware is. So for example, we look at its file properties, we look at the file headers, we look at the strings inside, we check whether it's packed, things like that. We look at what malware is without actually running it. Now, dynamic analysis concerns itself with the question of what the malware does. Like what actually happens when you run the malware, all right? So that's basically the idea. One example is, for example, let's say our malware is packed, right? If the malware is packed, then provided we cannot unpack it, then the only way to find out what it does is by running it. In fact, running the malware is actually a surefire way of unpacking it. Because you see, before the malware runs, even if it's packed, it has to self-unpack. Otherwise, it cannot run. So that's why dynamic analysis can help us with this. All right. So even if the program is unpacked, even if the program is packed, we can run it and still observe its behavior because it cannot run without unpacking itself and actually doing what it's supposed to do. Like, for example, if my malware is programmed to connect to some domain and to download some malicious content, well, whether it's packed or not, that's what it's going to do when the malware is ran. All right? So that's basically the idea. All right? So, one quick thing before we go on. So as you know, the quiz grades are up online. I wanted to quickly go over something. So some of the questions asked about the host-based and network-based indicators. So a few things which I wanted to mention about that. So first, please remember that the indicators, they are behaviors, okay? They are behaviors of malware. Like for example, creating a certain file, okay, starting a certain process, connecting to a certain domain, all right? So basically, when you look at the malware, and let's say you discover something that looks like a file path, and you're trying to talk about a host-based indicator, you want to say that, the malware might be, for example, accessing, creating, downloading this file, okay? So basically, use it in a sentence with a verb, okay? So that's basically the idea. And also, another thing which I wanted to talk about is when you talk about the host-based and network-based indicators, as we talked about in classes, that you want them to be identifying, okay? So for example, if the malware is accessing some common DLL file, or for example, it is trying to connect to google.com, those are not really great indicators because a lot of legitimate programs do that. So it'd be very difficult to identify malware based on that. Like basically an indicator is if I see it, it raises a red flag, okay, which is indicative of this particular malware being present, okay? So just two things I wanted to quickly mention, all right? And we also talked about the fact that dynamic malware analysis can be more efficient than static because static malware analysis, it can tell us everything that the malware can do, but it doesn't say everything that the malware will actually do, okay? So if I study the code of the malware, like I disassemble it and I study the assembly code, yeah, I mean, I could find out in theory everything that the malware is capable of. But that'll take me a long time, and some of that stuff might not actually happen when the malware is ran. Perhaps it's a decoy. Perhaps that code executes only very rarely. Okay, so that's basically the idea. All right. So very often when we do dynamic analysis, we will monitor the malware as it runs, we'll look at its activities, and then we'll look at the changes that the malware has made after its execution is finished. Now, also another important thing to keep in mind as we work on basic dynamic analysis is that basic dynamic should always come after basic static. Okay, you shouldn't be ever running malware or doing any kind of analysis that requires running a malware before you do the static analysis. Okay, because the static analysis is it gives us a little bit of information about what the malware is, which number one can help us make sure that when we run the malware, we are not doing anything silly. For example, perhaps the malware is designed to do something for which I haven't accounted for. For example, let's say that it is programmed to break out of a sandbox. Okay, so if that's the case, I want to make sure that I put in proper protections in my sandbox to prevent the malware from getting out. Okay, that's one example. Yeah, malware can try to break out of sandbox. In fact, such malware does exist. All right. Another reason is that it will help guide your dynamic analysis. So, for example, think back to your assignment one. You know how you've seen that the malware can, for example, try to access www.practicalmalwareanalysis.com domain, or you've seen malware that is capable of creating files with different names. So during basic static analysis, you would take notes of all of that, and when you do dynamic analysis, for example, you run a process monitor, proc1, you would be looking for those kinds of activities. So for example, if in the basic static analysis you did a string dump and you've seen that malware creates a file called malware.txt in my documents folder, well, perhaps you should be watching out for this behavior when you do basic dynamic analysis. So dynamic and static, they work together, okay? You need both, and static always comes before dynamic. All right, does that make sense, folks? Any questions? Okay, we're good? Yeah, so just a quick review there. So, and Carly's asking, do we need to have any escaping rules in this class? For now, not really. Later on, possibly. All right. So we also talked about sandboxing. So sandboxing provides us a safe environment in which we can study malware. There are many sandboxing solutions out there, and the sandboxing solutions come in all shapes and sizes. They can provide different kinds of tools which monitor how the malware runs inside the sandbox, monitors its activities, tells me what the malware is actually doing. Okay, so but despite the fact that there are so many sandboxing solutions out there, sandboxing has many limitations. One is, of course, malware might be able to detect the sandboxing environment and hence resist eliciting its true behavior just to frustrate analysis. And there are tools which you can use in order to see what the malware might be able to see that runs inside your sandbox. One example of that is called paranoid fish. Okay, so yeah, paranoid fish. Also, another limitation of sandboxing is that sometimes malware needs to be invoked with certain parameters. Like, for example, I may have a worm malware that has to be invoked with command line switches, -attack, and the IP address and the port of the system to attack. If I run it inside the sandbox without those parameters, then I won't be able to see too much. Okay, malware will probably just terminate without doing anything. So that's why doing basic static analysis is so important. Okay, because it can tip us off to those kinds of things. All right, are we clear? And no, in this class, I don't plan to give any malware that escapes out of the sandbox because Well, number one, that can be a bit risky. And number two, malware that tries to escape the sandbox is really not much different from the regular malware. It just tries different exploits. That's all. All right. So that's basically the idea. Also, another limitation of sandboxing, which we talked about, was that, well, how long do I run the malware inside a sandbox? Because let's say my malware is something like a logic bomb, or let's say it is something, something that gets triggered only every time whenever I connect to a certain website. So the question is, for how long do I run the malware before I can conclude that it's doing this or that? Because, for example, a logic bomb may lay dormant until Friday the 13th, right? Like Friday. And such malware did exist. Okay, so it's really hard to say how long I have to run the malware inside the sandbox before I can draw any kinds of conclusions regarding its behavior. All right. Also, malware may require specific kinds of environment to run in. So, for example, a 32-bit environment or a 64-bit environment, or perhaps malware may require that certain programs or files or softwares are present inside the sandbox. So when you're constructing your sandbox environment, you want to make sure that you account for that. Okay? All right, we talked about that. So we also talked about the fact that malware may be hiding its functionality inside of the DLL file. And as we talked about in the last class, DLL files are really no different in some sense from the exe files in Windows. Because in Windows, both DLL and exe files are formatted according to the PE file format. PE stands for portable executable. Okay, both of them, are just a bunch of PE headers followed by a bunch of PE sections. All right. Now, DLL is basically a file that contains a bunch of functions that it exports. And in the last class, we talked about how we can run any function inside any DLL. So basically, we do run DLL32, the name of the DLL file, followed by the name of the function which you would like to invoke inside of the DLL file, and then any arguments which you want to pass to that function. So in the last class, if you remember, we looked at an example where we have ran a program. We ran a function inside the DLL which locked and unlocked the Windows workstation. Actually, well, just the one that locked the workstation. We didn't unlock it through the DLL. All right. So here's an example. Run DLL 32.exe, and this is the file in which we would like to invoke the function, and this is the function that we would like to invoke. Lock workstation doesn't take any parameters, and another example of a function that does take parameters is the control run DLL function inside the shell 32, and this is an example of an argument that we can pass to it, timedate.cpl, which tells the function to basically run the Windows XP time applet. All right. Any questions? And Carl is asking, should I reload the snapshot? I think something could be logic bomb. So sure. You can definitely reload the snapshot. All right. So far, so good. Yeah. All right. Excellent. So the next, and we also talked about the fact that you can invoke files, that you can invoke functions inside of a DLL file, either using the function name or using the ordinal number. So the ordinal number is the function number. So each function inside of the DLL file has a number which you can use to invoke it. An example of that is, let's say that I want to invoke function number 5 inside of a file xyzzy.dll. So it's very simple. Just run dll32.exe and the name of the DLL file followed by pound and the function ordinal number. So and we can find the function ordinal number inside of the sandbox, we can run this inside of our Windows XP sandbox. So for example, the first step would be to use dependency walker to look at a particular kind of file, right? I can look at xyzzy.dll inside of a dependency walker, and then find its ordinal number of the function that I want to invoke, and then just invoke it like this, replacing 5 with the specified ordinal number. All right, are we good? So, Carla is asking, is an undetectable sandbox theoretically possible? Theoretically, yes, but in practice, this has never been done because sandboxing, which usually relies on virtualization, it just has so many side effects that malware can detect. So possible in theory, not so possible in practice. Okay. And Lauren is asking, I was trying to run function examples, but I saw in the preview, most of them didn't have a number. It would say NA. Yeah, that is possible. That is possible. Some functions don't have an ordinal number. And they can be invoked only by name. Yeah. It's that, or sometimes dependency walker may just fail to detect them. That's also a possibility. Okay. So, and I think Joseph had his hand up.
Yeah, so for the ordinal numbers, are those standardized based off the library, or is it just like a compile order, or how does that work? What decides the ordinal number?
Yeah, basically it's decided by the developers of the DLL file.
Got it. So it's going to be standardized, and if you're ever using, for example, ZY, XY, ZZY, it would always be number 5 is number 5.
That's right, yeah. Unless the developers modify the file and change the function's ordinal number. In terms of the standard Windows DLLs, it basically Microsoft goes out of its way to maintain reverse compatibility. So it is highly unlikely that we'll see an ordinal number change in a Windows DLL.
Got it.
If that makes sense.
Thank you.
Yeah. If you remember a while ago when we talked about Microsoft's function naming conventions of the functions inside of the DLL, like whenever Microsoft wanted to upgrade the function, they didn't just modify the old function, they would create a new function which is named the same way as the old function, but just followed by a suffix of ex. Remember that, to represent extended, while leaving the old function so that older legacy programs can still work just fine. All right.
Right.
So yeah. So so the point is Microsoft goes out of its way to maintain backward compatibility. So it's very difficult to imagine that they would be changing ordinal numbers after all this effort, if you know what I mean.
Makes sense.
Yeah. Yep. All right. Any other questions?
I had a question just regarding when you run or invoke an actual function number. Do you usually see an output, or is it just in general it's something you'd have to see maybe in like PView or dependency walker?
So when you run a function, are you supposed to see some kind of an output?
Yes.
Was that basically the question?
Yes.
Not necessarily. You will only see output if the function that you run is supposed to produce output. Some functions may produce command line output. Some functions may create in some kind of a GUI event. Like, for example, it will pop up some kind of window. Like, for example, this one, it'll pop up a printing window offering me to print this file. This one will pop up a Windows applet. Like Workstation, I mean, it isn't really going to output anything, but you'll know that it's ran, of course, if your system locks up, right? But some functions, they are not really designed to produce any kind of output. Some functions are just designed, for example, to change some kind of a system setting. So no, so not all functions will actually produce any observable output or GUI event, if that makes sense.
Yeah, thank you. That helps a lot.
Yeah, it all depends on the function. So, all right. And, in malware specifically, like let's say you have malware that is using its own DLL file for stuff, or perhaps a malware itself is a DLL file. Well, then it'll probably try to produce as less output as possible in order to remain stealthy, right? So let's see. We also quickly talked about the Windows registry. That's basically where Windows stores a lot of its settings. It's like a database of Windows settings. We'll talk much more about registry today and how to observe the changes to the registry to infer what the malware does. In fact, we will revisit Windows registry multiple times throughout the class, just because it is so important. And so we talked about that. Now, and we talked about a very important tool in the last class, which was Procmon. So who is Procmon? Well, Procmon is the process monitor software which can be used in order to monitor the behaviors of all processes on your system. For example, you can see what operations are they performing on files, what changes the processes are making to the registry. You can even see attempts to establish network connections. And in the last class, we looked at how to use Procmon in order to monitor malware and to find out what kinds of operations it is actually performing. One of the useful features which we looked in the last class that is related to Procmon is the filters, right? So because if I just run Procmon like this, you can see that I'm seeing events for all processes on my system, and that's a lot. If you look down here, you can see that the events are coming in at a very rapid pace. All right, very rapid pace. And I don't want to know what all the processes are doing. I only want to know what my process is doing. So, like an example, which we looked at in the last class, like let's say that I'm going to start Notepad, right? And let's say that I want to monitor the activities of the Notepad. So that's where filters come in, right? So we go to filter and choose filter, just like that. And then we specify the criteria for monitoring the process behavior. So first, in the first column, I specify what I want to match the process by. So I'm going to choose process name and the condition. So I'll choose is, basically meaning that I want the process name to exactly match. And I'm going to choose Notepad from the list of active processes. And if that's the case, I'm going to include the process in the list. So I'm going to click add, I'm going to click apply, and I'm going to click OK. And as you can see, now the only activities that are there are the ones for Notepad. Okay. So yeah, that's basically the idea. Now, let's say I create a file with a Notepad and I do file, save as, and yeah, desktop is fine. And I'll call it hello or hello.txt. Boom. Now, as you can see, somewhere the Notepad has opened that file called hello.txt, and there it is. Okay, so I can see the event called create file, and this is the path that it's targeting. So it's targeting the path C documents administrator desktop hello.txt. Then it calls a write file function, and then it set and file information file. This is another file operation. We can always look it up. And does some other stuff, and finally closes the file. Okay. By the way, folks, the key idea here is, once again, as you're monitoring things in Pracman, don't go in blind. Use what you learned in the basic static analysis in order to use Pracman effectively. Because, for example, right, all of those functions which it is invoking are the functions inside of the DLL file. When you did your basic static analysis, right? For example, you use the dependency walker, and what you want to do is in the dependency walker. So let me quickly bring up Notepad and just drag that into the dependency walker. It'll probably import 3 billion DLLs. Not 3 billion, just like about 1 billion. So, and we can look at some of the functions that it imports. So we can see it imports a GDI DLL, imports a bunch of graphical stuff. But let's see, let us look at the DLLs, which would normally store some of the functions that we have observed. So here are some of the file related functions that it imports. And there is the MSVRT, contains some of the basic C operations, the GDI, which is for the GUI. And as you can see, most of those functions are GUI functions. We got kernel 32.dll. And in here, we can actually see a lot of the file functions. So for example, the create file function, okay? Somewhere in here, we will see the write file function. Where is the write file function? It's probably toward the end. There it is, okay? And there is the write file function. So in dependency walker, we've seen that this program imports a write file function from kernel 32.dll, and behold, here we can see that it is calling that function. So you see how dynamic analysis can actually verify what we observe during the static analysis, because before we did dynamic analysis, if we saw the program importing a file kernel 32.dll, and from that it imported the write file function, basically all we could have said that it might be trying to write a file. The reason why we say it might be because just because the program imports a particular DLL file doesn't actually mean it'll be using it, okay? But since we are in the dynamic analysis now we can actually confirm that yes, it is indeed using that function in order to write a file, okay? So I use my findings in the basic static analysis to monitor to watch out for things during dynamic analysis. So for example, if I did the basic static analysis and I saw that the program has a file path in the string dump, well, I might want to be watching for this for access to that file path in Pracman during basic dynamic analysis. All right, does that make sense, folks? Right? So always do basic static analysis first, and then use your findings to help optimize and drive the basic dynamic. All right. And Joseph is asking, we can also filter by the path, right? Of course. Absolutely, yeah. Filtering has a lot of different options. So see right there, there is a path. So we can also filter by the path accessed. In fact, what you can do is you can actually add multiple filters. One filter that is filtering by the process name, and another filter that is filtering based on the file access, based on the path. So it would filter out all processes except your specified process, and then from the output of that process, it would filter out everything that doesn't match the specified path. Okay, make sense?
Yep, thank you.
Yep, sure. All right, so that's basically the idea behind that, okay? And today, I also would like to learn about another tool that doesn't quite get along well with the process monitor. Okay, it really likes to crash the VM when you run them together. Sometimes, okay, and sometimes it doesn't. So be warned. So I'm going to run Process Explorer and let happen what might. All right, so here I have started the Process Explorer, and Process Explorer gives me detailed information about running the processes. So on the left-hand panel, we can see the process tree. If you folks remember operating systems, right, processes can create other processes which are called the children. So, and we can see examples of that. So, for example, the system process has created a child called interrupts. Interrupts has created a child called csrss.exe. Also, we have the win login process, which is the child of smsss.exe. And there is the services process, which has the child of vbox service. Yeah, basically, it gives us the family tree of all processes running on the Windows system. Aren't they just one big happy family? So that's basically the idea. Yeah, the kid processes. Now, so what can this tell us? Turns out it can tell us a lot of super useful kind of things. Just looking at it, we got a bunch of indicators which show us the CPU usage, the system commit, which is the memory management, the management of the virtual memory. We got an indicator showing the management of physical memory, like how much of that we got left. We got I/O information on how loaded is the I/O, network, disk information, and GPU information. So we can see them all right here. And if you ever forget which one is which, you can always just move your mouse over them and it'll tell you. It'll even give you a quick statistical summary. Okay, and if you want more details, you just click on it and you can see the very detailed breakdown. Okay, so that's the first thing. Now, another very useful thing about it is that, let's say that I select some kind of a process. Let me start Notepad again, so we can use it as our guinea pig. There it is. So if right here, it gives me some information about the Notepad. Like it gives me some information about its memory. It gives me its process ID, which is 424. So each process has a unique process ID, which is just a positive number. So the process ID of the Notepad is 424. It also gives me information about the manufacturer, if that information is available inside the program. Now, there are a lot of things that I can do here. So I can, for example, dump its memory. Now, when I do memory dump, it will basically take the memory of Notepad that is currently in RAM and dump it. Okay, that can be very useful for monitoring live malware. Probably some of the most useful stuff that we will find is in the properties. It gives us so much useful information. So this one is just the first panel, which says the image. It basically just gives us some basic information about the program, like its path, what command line was used to invoke it, in what directory it resides, and so on and so forth. This just gives us some performance information. The performance graph, the disk and network, that's not really that interesting. What is interesting is this string step. It basically gives us the strings. Now, if you click on the image, it gives you the strings inside of the executable itself. All right? Basically the same kind of information that you can obtain by running the strings program or by using PStudio. But what about the strings in the version of Notepad that has been loaded and is running in memory. Well, to do that, you would click right here, and it will give you all of the strings in the current memory of Notepad. And by the way, at any moment you can click save, and you can find them, and you can save them. You can also search for certain strings. What else? Yes, the environment. That's quite interesting because it gives us access to all of the environment variables that this Windows process is using. So environment variables are basically Windows settings that are represented as a bunch of variables that are accessible to programs. So, like for example, all users profile is the location of the all users directory, which is the standard directory that stores profile information. The location of the app data, which is another common Windows directory. For example, the OS variable stores the version of the operating system, which Windows XP thinks of itself as Windows NT. The location of the program files directory, and so on and so forth. So sometimes that may be useful. Security is the different privilege levels that this program has. We'll talk about that later. This is interesting. The TCP connections stores information about the different TCP connections that the program has opened. Now, this list right now is blank because, Notepad does not initiate any TCP connections to anywhere. Okay, and then there is the threads tab, which gives you information about the threads inside this process. If you folks remember, a process can be doing multiple tasks at the same time by creating different threads. So each thread is like a different task that is executing inside a process. I hope you remember something from the operating systems. So we've seen this. Let's see, anything else? Yes. So another thing which we can find out is if we go to view, and if we select columns, you'll see that we can add a lot more information. Okay, so like for example, I can add a window title. Okay, so now somewhere in here there should be the window title. So the window title is basically, if this is a graphical program, then the title would be displayed right here. Okay. Professor. So that's, yep, go ahead.
Really quick, on Notepad, when you went to the properties, do you have to do that within Process Explorer, or could that be done just on any function, just right-clicking and going to its properties to see strings and stuff?
You have to do it from Process Explorer. Yeah.
Got it. Okay, thank you.
Yeah. And also another very interesting function is this one. Okay, like let's say that I have just started my program, and it's a graphical program, and I don't know what process it corresponds to. In fact, a single application can consist of many different processes. Here is a pretty cool feature. Do you see this target? Right? So if you click on it, or rather, if you click on it and hold it, do you see how my mouse becomes target shaped? And then I just drag this target into the window that I'm interested in. Do you see what happened? Basically, Process Explorer has automatically selected the Notepad as the process that owns this window. I want to see that again. So like, let's say I have selected something else. So just click on it and drag. Boom. See how it has automatically selected that? So a very useful feature that you should definitely consider using while you're using the Process Explorer. Let's see. What else is interesting? What do I want to do? Let's see. Let's see. So we looked at that. We looked at.
How did you do that? Did you hold down a button before you start moving the notepad?
Uh, the target.
Oh, the target. Okay, got it.
Yeah. So
I missed that.
you press and hold, press, hold, and drag.
Got it.
Okay. Yeah. So yeah. So that's basically the idea. Let's see. And this can allow us to create a dump of the process memory. I still have Notepad running. So if I do right click and create dump, and if I do create full dump, and it's going to save it into the DMP file. All right, so it's taking a dump. All right, and there is the dumped file. Okay, so by the way, if you want to get the strings inside of a dump file, well, you can do something which we've been always doing. So I would just do strings.exe. And by the way, this dumps the memory that is in RAM. So, and I can do dump str, for example. Before I do that, let me navigate to my desktop.
Is there a difference between strings.exe and just strings?
No. Windows will figure out the name regardless. So either one is fine. So and I'll just click out.txt this time. So basically, it has extracted all of the strings from my dump. And as you can see, there are a lot of strings there. All right. Lots of different strings. Let's see if 458 is there. And there it is. See, there is that string that Notepad had in memory somewhere. Does it make sense? So we can actually see what the malware was thinking. Because you see, if I do the string dump of just the notepad.exe file, I won't be able to see this information because, well, it's just not there, okay? The information doesn't get there until the notepad is ran, all right? That's the power of dynamic analysis, okay? Does that make sense? So, all right, so we got some questions. So Carl was asking, yeah, the VirtualBox does have side effects. Is the process ID of the program set in stone or can it be changed? So in Windows and Linux, it's basically set in stone. It cannot really be changed. The refresh, it varies. I've seen that happen. And Carl is saying Notepad has only 2 threads. Yeah, it looks like it, which makes sense because Notepad is not a terribly complex application. So, and Lauren says, wait, do you press the target and then drop it? Yep. So basically, just click on the target, hold it, and then just drag it into the window that you want. So for example, I just dragged it into this window and it has selected the right instance of the Notepad. All right. So, and how do you read the dump file? Generally, you would read the dump file using the hex editor, okay? What I did right here is I basically did I just extracted all of the strings from the dump file, okay? And behold, that's what we found. We found what the Notepad was thinking at the time when we dumped its memory, all right? This is a very powerful live forensics tool, folks. Does that make sense? Yeah?
Yeah.
Yeah. Now, do you see this icon right here? It says show lower pane. It looks like sort of like a split window. If you click on that, it'll also give you this panel right here. Very useful thing. So it basically gives me all of the objects to which my Notepad currently has access to. It includes files. It includes registry keys and things like that. It includes semaphores, the things that are used to synchronize processes. All right. So, like for example, there is a semaphore at this location. There is an access to the object called Windows Station. There is an access to the desktop object. There is an access to some directory. All right. So, and that's basically the idea. All right. Let's see. Let's see. Do I want to talk about handles right now, or do we save it for later? So another thing which we can do is we can search for the DLL handles. We will learn about that later once we get to it. But basically, what it allows you to do is to search for handles open to the DLL files. A handle is basically it's like an object that is used to control another object. So whenever a malware opens a DLL file, it has a handle to it. So we can observe those handles. And let's talk about that. So right now, I can also choose show unnamed handles, which will basically give me all of the handles that are opened by this process that don't have a particular name. You see, all the handle objects, they typically have a name, but not always. So now we can also see the unnamed handles, right? To see the handles, you basically need to first enable the this window down here by clicking on this icon right here, okay? And it'll show you all of the handles. If you want to see unnamed handles, you would go to show unnamed handles, all right? So that's basically the idea. And by the way, I can manually refresh by doing refresh now. All right, so any questions so far? Very powerful tool here, folks. Very powerful tool. Questions? Yes. Okay, so let's see. So we have a question. Is there any way to make the text larger for those watching on a laptop? So I guess it's possible. Maybe like that. Is that better? Yeah. Yeah, unfortunately, this is not possible on all of the programs that we use, but Process Explorer developers have thought of this, okay? Yeah, I'll try to do it as much as possible, and then in the videos, I'll try to add some zooms to hopefully help with that. All right, so that's basically the idea. All right, so questions? And Lauren's asking, can you show how to get the events again? Yeah, so basically, once again, to get the events, you would click on this icon right here, show lower pane, and it will show you by default only the handles that have names to them, like this one. Okay. If you also want to see the unnamed handles, you will go to View and Show Unnamed Handles. All right. So that's basically the idea. Right?
Professor, why would we want to be able to view the unnamed handles?
Oh, many reasons. Like, for example, this handle right now represents a directory that has been opened by this program. So currently, this program has this directory open. So that's something we definitely want to be able to see. Or, for example, if a program currently has some kind of a file open right now, right? We want to be able to see that. We also want to be able to see what semaphores it creates, because malware also can use semaphores, as we'll see later on, in order to, for example, prevent multiple copies of the same malware running at the same time. So handles are of immense interest to us, if that makes sense. Also, what happens if malware opens handles to the desktop object, to the screen object, and things like that? They can give us quite a lot of information about what the malware is trying to do. Does that make sense?
Yeah, it does. Thank you.
Yep. So, and Lauren is asking, Oh, okay, gotcha. Okay, so we're good. Okay. So folks, definitely use Process Explorer as in your analysis. It'll definitely help. Sometimes, like I said, it doesn't get along very well with Procmon when you run at the same time. But let me try running it right now. Will that work? Nope. Yeah. So as you can see, how do we show the unnamed handles? So we just went over that a few times, but let me show that again. So basically, once again, click right here, go to view, and show unnamed handles. Oops. Yeah. Okay. Yeah, that's basically the idea. All right. So yeah. All right. Now let's move on and let's talk about Windows Registry in a little bit more detail. So what exactly is the Windows Registry and why is it important? So before we talked about the fact that Windows Registry is basically a database of all of the Windows settings, and the basic components of the registry include the keys and the values. First, let's talk about the values. So a typical Windows Registry value looks like this. By the way, to run the Windows Registry editor, you would go to run and type in regedit, okay, and that's what it looks like. And all right, so that's what it basically looks like. Now we can select almost any folder on the left-hand side. A folder is also referred to as the key. We'll talk about the keys in a moment. And then on the right-hand side, you will see what's called the values. So any registry value has three different attributes. They are as follows. First is the name, okay? So, and the name of the registry value is basically something that describes it. So like, for example, the name of this registry value is perceived type. Next, each registry value has something called a type. So registry values, they can be strings, they can be numbers, or they can be other kinds of values. We are most interested in those two, at least for now. The reg as z is means that this registry value stores a null terminated string. Okay, and if we look in the type column, we'll see the type of the registry value described. So if we right click on it and we choose modify, we can see that this is the value, this is the data that is stored inside this value. The data is called system, a string called system, and because the type is regz, right? This the value data represents a null terminated string. Okay, so and once again, the registry editor it can be ran if you go to start run and then type regedit. Okay, like that. I just posted in the chat. So that's basically the idea behind this. Now, the value type can also be, for example, reg dword, which means that this registry value stores the data whose type is a 32-bit integer. Okay, so that's basically the idea. Let's find one such value. So we see a bunch of strings so far. There's got to be one somewhere. Let me scroll down to. We'll find one eventually. Oh, okay. So here we see reg binary. which basically means it stores a binary value, but I want to get the integer one. Or we can always just create one. So I can create a dword value. So right-click, new dword value, and then I can click on modify, and I can give it a name. Well, actually, I have to give it a name from the console. And then as the value, I can put in a 32-bit integer. And by the way, I can do it either in hexadecimal or in the decimal format. Okay. And that's the value that it stores now. And if I wanted to modify that, I can just click rename, and I'll call it my value. Okay. Oh, it doesn't matter what folder I'm in. I just arbitrarily chose one, and in it I created this binary value. Okay. So, all right, that's basically the idea. And if you want to delete a value, you just select it and you press delete, and it'll ask you, "Are you sure you want to do this?" And you'll say yes. Okay. That's basically the idea. Now, so the keys basically are collections of multiple values. They kind of look like folders. So all of the keys you will see on the left-hand side, and each key will typically store multiple values. So whenever I click on a key, so for example, right now I just clicked on this random key, and inside this key we have 3 different values. Okay. Does that make sense, folks? Are we good? Where is the key? So like, once again, the keys are on the left-hand panel. So all of those are the keys. Okay. And I just chose an arbitrary key as an example. Yeah. A key is a collection of values. All right. All right. So that's basically the idea. All right. So, and if you forget that, I did include a label. So here we have the keys, and each key contains a bunch of different values. All right. Now, why are we so interested in Windows Registry? Well, because malware often makes changes to the Windows Registry. Why does it do that? Well, changing the system settings is something which can be very beneficial to the malware in order to accomplish its nefarious tasks. One example includes having the malware run itself on startup. Okay, so for example, the part of the registry which stores the programs that are to be started on startup, they are stored in HKey current user software Microsoft Windows current version run key. Okay, so just to see where that is, let's actually navigate to that key. And by the end of this course, you will probably know this key by heart, just because this is something which we'll be examining so often. All right, so I'm going to go to HKey current user. So just uncollapse that key. Next, I'm going to go to software, uncollapse that. I'm going to go to Microsoft, and I'm going to uncollapse that. And then I'm going to go to Windows, and I'm going to go to the current version, and I'm going to click on Run. Okay, this is where the programs that should be launched on Windows Startup typically reside. All right, now right now I don't really have anything to start on the program startup, and that's why this is empty. if I wanted to start a program on startup, like let's say Notepad, right? What I would do is I would simply go to new, create a new string value, give it a name. So for example, Notepad. And then I'm going to do right-click modify, and then I'm going to put the path of the program that I want to launch. So C Windows, and I'm going to test it. Oh, I just knew that Notepad was in C system Windows 32. Okay, yep, that's valid. So that's what I'm going to do. So I created Notepad, and I set it to Windows system 32 notepad.exe. Okay. Typically, you would have to know the information of the executable. Whenever you're not sure where a program is, you can always look it up like based on the shortcut. You can right-click on the desktop icon and go to properties, and it should have the path in there. Okay. So there it is. See? And there is a notepad. Okay. I'm sorry about that, folks. Yeah. You have to put in the actual path. Okay. All right. Are we good? So, and malware will often try to modify registry in order to make itself start on the startup. Now, so how can we monitor malware's changes to the registry? Now, of course, we kind of already know one way, because we have our beloved Process Explorer. Please don't crash the system. And no, that's Procmon. I'm going to run. And because we got our beloved Process Monitor, okay, which will probably crash the system, because I have previously ran Procmon. So I'm going to use Procmon in order to monitor changes to the registry, and that's useful. That's definitely useful, but we'll also see a post-hoc method. Yay, Carla got it to work. The notepad is not working. So here is what I'm going to do. So once again, Procmon will allow us to monitor registry live. There it is. And what I'm going to do is I'm going to launch regedit. And I'm going to monitor regedit in Procmon. So I'm going to do process name is, let me shut it down and let me go to filter again. Oh, it shows an architecture. Now let's do name again. Is, there we go. Regedit. Okay, and yeah, I want to see all of the events. Oh, we were editing. Edit now. Yes. There we go. Okay. So now, what I'm going to do is I'm just going to create a random registry key or a random registry value in the registry. Boom. Did you see that? So, and I'm going to call it hello. Do you see, as I'm modifying the registry key, how I can see Procmon monitoring those events? So for example, when I first created a registry key, it has invoked a function called regQueryKey, which is a function used by the registry editor in order to get information about a particular key. Open key basically is a way to open a key, so to open one of those folders for access. And then there is the reg query value. This is a function which is used to check if there is a specific kind of value, and if there is, then it will basically say it's found. Now, you see how the result is name not found, and that makes sense because this this key did not exist before I created it. This value did not exist before I created it. Okay, so here it says new value number 1 because that was the original name of it. Okay, and then again it tries to query all of the values inside of this key, and it's looking for the value with the same name. And this time it's a success, okay, because the value exists. And so once the value exists, it calls a function called RegSetValue, which sets the value of the key, or I should say of the value. All right. So and then right here we can see a sequence of operations which renames this value to hello. Now let's say I want to modify this value. So I do right click, modify. So, and as you can see, there is a bunch of outputs which were generated in response to that. So reg query value hello, and let's say I want to set its data to CPC 458. Boom. Okay, so and you see how it has called RegSetValue, and it was a success. And if we kind of expand this column right here, we can see that it has written the data called CPC 458. So Procmon can also show us what kind of data is being written. Okay. So far, so good, folks. And like once again, all of those functions are documented. So if you ever forget what those reg set values do, they you can always look them up. Okay. So for example, reg, if you're not sure what the reg query key does, you can always just look up reg query key, for example. And oops, that's not the one I wanted. Reg query key. Or actually, yeah, it is. Yeah, reg query info key. Do you want to go there, or do I want to go for the exact name because they're kind of the same functions? But okay, fine. I use this one. So, this is the function, and this is all the parameters that it takes. And what it does is it creates a handle for opening a registry key. Okay. So it's basically used to open the registry key and to get all of the information about the values that are stored inside that key. What else is there? Like reg open key. I can probably even find it like this, reg open key. There it is. So reg open key. So, and what does this do? Well, so this function opens the specified registry key, okay? So basically it returns a handle to the open registry key and allows us to use it in order to read the contents of the key, which is basically the list of values. What else did we see that was interesting? Like reg delete value, probably here as well. So if I look for reg delete value, and there it is, removes the named value from the specified registry key. So if I see a function like that, it means I'm deleting some kind of a value. Let's see, what else is interesting? Reg set value, okay? Reg set value. sets the data for the default unnamed value of a specified registry key. So basically it takes a value, and assuming the value had no previous name, it sets its name. All right? Make sense? So are we good? Questions? Carlos says, I missed everything. What did you miss? Like which part specifically, or like everything? Basically, all we did was we started process monitor, and we set the process monitor to monitor the reg edit process. So we did filter, and we set up the filter so that it monitors the reg edit process. It's somewhere in here. There it is. Okay, and then we click that. So now we are matching by the process name, and then basically we just played around with the registry editor. We did things like we created new values. So like here, let's make another string value. Let's call it kitty reg. Okay, a cat registry entry. So, and when I click enter, we've seen the set of registry operations that the registry editor had to perform in order to create this value, whose name right now is kitty reg. Okay, so basically we can see it right here. First, we opened the key. Okay, we got the contents of all the values in it, and then I have created a new key, and then I have renamed it to the key called kitty reg. Now you see what's happening here is that it says reg delete value, and the reason why it says reg delete value is because when I renamed it, there is really no renaming of the key behind the scenes. It looks like it just deleted the key with it deleted the value with an old name and just created a value with a new name. All right. So that's basically the idea. Okay. Questions? Are we good? Yeah. So this is how you can monitor registry in real time. Okay. Yeah, cool. And are the rest of you folks good? Any questions? 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 Ellie's asking, did you edit the name of the value in place? Yeah. Mm-hmm. Yeah. And I just chose a random key to do it under. I chose this arbitrary key. Generally, by the way, when we are working on our own system, we shouldn't be modifying the registry haphazardly like this, because you can do damage. But who cares? We're inside a sandbox. So, okay. Does that make sense, Sally? Yeah. Other questions? Does it let me edit system32 in the VM? Sure, yeah. You can mess with your system32 directory. So system32 is not a registry entry, it's a directory, okay? So, but you can mess with it in Windows Explorer, the file manager, all right? Do you folks get the basic idea behind how we can use the process monitor in order to monitor the registry activities of a process? Yep. And you'll definitely get much more practice with this. As you can see, it is very, very powerful tool. So Yeah. So, and Carl's asking, is the show events turned off by default? I had turned back on. Usually it's turned on by default. Maybe you have turned off before. So you have, in that case, you have to turn it back on. I've had to do that actually multiple times. So yeah. Yeah, and so, and it looks like we're actually right at the breakpoint. So once we come back, folks, we're going to learn about another tool which can be used for monitoring registry before and after malware executes. So we will take a snapshot of the registry before we run the malware, and then we will run that program again in order to get another snapshot of the registry, and then compare the two snapshots. And it'll show us what changes have been made to the registry. Okay? Does that make sense? Oh yeah, I get it. Yeah, breakpoint. Yep, the programming joke. Yep, like in debugging. All right. So folks, would you like to take a break right now and then come back and talk about another real useful registry utility, and then we will play with some hands-on with registry exercises. Okay? Sounds good? All right. All right, so let's go ahead and let's take a 10-minute break, and then we'll come back and the fun will continue. It's like back in the old 90s days, right? You know, don't go away. Your favorite cartoons will be right back. All right? So, all right, folks. So go ahead and take a break. All right, everyone. So welcome back. And what are we going to do right now is we're going to run some malware and observe the changes it makes to the registry. Now, so what I like to do is first I want to cover another tool which will be very useful, and then we will go ahead and run the malware. And the tool which I'd like to talk about is called RegShot. Okay, there it is. So RegShot is a tool which basically does what it says. It allows us to make a snapshot of the entire Windows registry, save it, and then we can run the malware. And then once the malware terminates, we can get another snapshot of the registry and then compare them. So RegShot is nice enough to do that for us and to generate a nice report. Okay, so how do you do that? Well, first, I'm going to select RegShot. So, and we can find it if we go to the directory called RegShot. It's in your desktop. You can actually keep Procman open. Okay. Somebody's asking whether we should close Procman. You can actually keep it open because it'll be useful. So, and I'm going to click on the directory, and then there's going to be the CLO executable called RegShot. So I'm going to click on that. All right. So, and a very small dialog like this is going to pop up on your screen, and you have two choices where you want to save your registry. One is the HTML document, the other is plain. You can keep it at the HTML document. That's perfectly fine. And to capture a snapshot of the registry, what you would do is you would just click first shot. Okay, and then it'll pop up this menu, like what do you want to do, shot or shot and save. I'm just going to do shot. Boom. So what it's doing right now, it is creating a snapshot of the entire Windows registry. It's taking a little bit because Windows registry is a big place. Okay. So boom. Okay, it's done now. Okay, and then what I'm going to do is I will go ahead and I will just make some kind of change to the registry. I'll just create a new value. Okay, and I'll call it my malware value. And I'm going to set its data to cats have superpowers. Okay, a statement that is funny because it's true, right? So no, it is true because, for example, my cat controls my life, although she's in New York. All right. Okay. So now, so I have just made a change to the registry, and now what I want to do is I want to bring back RegShot, and to create a second shot of the registry, I'm just going to click the self-descriptive second shot button. So I go click and I do another shot. All right, so now it's taken another snapshot of the registry. And once it is done, we'll be able to compare them, hopefully.
Professor, where did you edit the registry? What was the, or does it really matter?
Yeah, I just created a random value inside of a random key. I chose the dot WMDB.
Got it. It doesn't matter since we're just showing that how
Not
it
for this
will capture differences between shot 1 and shot 2.
Yeah. My choice was completely arbitrary. So yeah. So feel free to choose any other key and to create whatever value you want. Okay. So doesn't matter. Okay. So now that we got the two shots, we're going to click the compare button. Oh, sorry, not compare. It's compare. Okay. Compare. Is that how you read when the letter is capitalized in the middle? It sounds like a name of some French superhero. Anyway, just an idea. Now I'm going to click compare, and that's where the magic happens. So it has compared my two snapshots, and it's going to open up my browser, and it's going to show us all of the differences. Okay, let's make it bigger. So basically, it has like some information when the two snapshots were taken, some information about my computer, and then it'll have different categories. So the first category tells me all the new values that have been added. And behold, it says that one of the new values which was added is a value called my malware value, and it was added under .wmdb key. Okay, and the value was set, and the current value is the data stored inside the current value is cats have superpowers. Okay, so those are the new values that have been added. Okay, now also some values have been modified. Now it looks like those modifications have nothing to do with what I did, because you got to remember, as the system executes, there are other processes all over the system that are modifying the registry and adding things and taking things away. So it is not surprising that I see some changes that are not directly related to the changes that I made. Okay, does that make sense? Okay, so that's basically the idea. Did Gary just betray us? Gary, how could you? Come on, do your thing. Bring back that beautiful malware. Maybe I'm just too far away. Interesting. I think it's not Gary's fault. I think it's Zoom's fault. Yeah. Well, anyway. Yeah, Reg added Zoom, right? So that's basically the idea. Do you see how this tool can be useful, right? Any questions? Yeah, and like Carla points out, she got 5 changes underneath the values modified. That's perfectly that's perfectly fine. Okay, so they're not related to what we did because something else has probably did the modification. And by the way, this RNG seed, this will always be updated. Okay. Yep. So actually, those you can usually ignore. Okay. Questions? Are we good?
So we know that most of the time the values that are modified could be due to other programs running in the background, but
Absolutely.
will we be also looking at those periodically just in case if our malware is dealing with our already existing values and messing with them?
Oh, absolutely. Yes, yes. Malware can modify existing values all the time. Like, for example, it can modify some of the values in the current version run very easily. Yeah, that happens all the time. Yeah. Does that make sense?
Yep. Thank you.
Yeah. No. I mean, definitely. Always keep that in mind. Definitely always keep that in mind, because you need to make sure that you are watching out for everything. All right, are we good? All right. Oh, now it's back. Okay. All right. So now, folks, yes. Oh, yes, we're going to be running malware right now. So, get ready and get comfortable. Okay. So make sure you have your comfort animal. Your comfort cat, comfort dog, comfort hamster, comfort cobra, whatever it is that calms you down, right? Comfort coyote, we got a bunch of those. All right. So what? Comfort python. Oh, I like that. Yeah. Comfort malware. Anybody got comfort malware? Yeah. Yeah. So what we're going to do is in the set of programs that I provided, we're going to click on the basic. We're going to go in there, and we're going to go into the exercises folder. Okay. So we're going to be running this program right here, but don't run it yet. Don't run it yet. Okay. So the first thing which I'm going to do is I'm going to take a snapshot of my VM, just to make sure that I can easily roll back the state of the VM if I mess up. So I'll call it before running the malware. Okay, so I'll create a snapshot. So I wait for it to complete. Okay, the snapshot is done now. And I'm going to do two things. So I'm going to start a fresh copy of RegShot, but don't take any shots just yet. And also, I want to be monitoring things in real time as well. So what we can do is in Procmon, we're going to go to filters, and I'm going to set up my filter to filter everything except one.exe. So I can actually remove my previous filters. Yeah, the new files are on canvas. Yeah. So, and process name is one.exe and include. Yep, that's what I want to do. And I'm going to click. No, not cancel. No, I click cancel. No. Okay, let's do that again. So I'm going to go to filter, and I'm going to remove my existing filters, and I'm going to click on add. And okay, so I'm going to select the process name is one.exe, and the answer and include. Yep. So I'm going to click apply, and I'm going to click yes, I want it in there, and boom. Okay. So here we go. And also I want to make sure that my Procmon is capturing. Okay, very good. And also I'm going to go to the RegShot now, and I'm going to click one shot or the first shot. Okay, so go ahead and do that. No, I'm not looking at regedit. Yeah, in fact, if you want to, you can close regedit. All right, we don't need it anymore. Okay, so and I'm going to click on the first shot to create the initial shot of the registry. All right. And it's done. So now we have everything ready to go, it looks like. So what I'm going to do is I'm going to run the malware. Ooh, right? Are you ready? By the way, did everybody get everything ready? Okay. Oh, gotta get your pet. Yep. Got your Procman ready. Got your RegShot ready. Got your cat and dog ready. Yeah. I want my mommy. Yeah. 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 So, yep. All right. So let's go ahead and run it, and let's hope that we can learn what's going on. Boom. Okay. So I just ran it, and looks like we got a bunch of activity right here, right? So, and then I'm going to do the second shot. It's taking a little bit of time, but that's okay. All right. And I'm going to click compare. So what do we see in here? Do we see anything interesting? So we see that some new values have been added. So, and one of the values is this one, and it looks like it's related to malware. And looks like we got another value which was added right here. Okay. All zeros. So, and then we can see some values right here as well. Now, it's kind of difficult to tell what they are yet, but we would generally take the notes in them. Oh, and those values, they're in just hexadecimal. And if we look at Procman, we will also see that we got a lot of registry activity going on here. And also a lot of this registry activity, it looks like it's modifying current control set TCP/IP parameter WinSock. WinSock, TCP/IP. What does it remind me of? Yeah, network, right? And also, one of the things that I noticed down here is we're seeing something we haven't really seen in Procman before. It's showing us signs of network activity. We see signs of it trying to perform TCP/IP communications to this IP address. It's trying to connect to some server, right? Very suspicious, right? So that's what it would look like in a real malware. So what the hell does this do? Well, I want to leave it as a bit of a cliffhanger. I just wanted to quickly show you what things look like on a real malware. And we're going to come back to it actually in a few moments. I just want to build up, after I shocked you like this, I want to build up your skill set just a little bit more so you get a bit more comfortable with this. So, and that's why we have created a snapshot. Yeah, you may or may not see the TCP communications. You won't see TCP communications if you have an enabled network. I have. You shouldn't do this right now, but I have, just so I could show you. Okay. So what I'm going to do now, I'm going to go to File, on my VM, close, and remember that snapshot I've taken. I'm going to roll it back. Okay. No, you're not crazy. You're not crazy. This was all by design. Okay. So, and we're going to go to basically restore. Okay. Let's restore our VMs to what they were before. And we're going to start the VM now that was freshly restored. And to build up our registry analysis skill set, what we're going to do is I have created a program right here which will help us see things in a bit the more pronounced way, which will help us then analyze the real malware. So once again, I'm going to configure my filter, but this time I'm going to configure it to something else. Okay. What I'm going to configure it to is to mystery.exe. So let's go ahead and let's configure our filters. So process name is mystery.exe, and we're going to want to include that. Okay, and let's get rid of our other filters. So regedit, remove that. Regedit again, remove that. And I already added this one, so I'm going to click apply. And I'm going to click OK. All right, good. And I'm going to do what I did before. I'm going to take the first shot of the registry. You may have to restart RegShot for this to work. So I'm going to restart RegShot. Wait, no. Where is RegShot? There it is. And there's RegShot. So I'm going to take the first shot. Boom. There it goes. All right. Almost done. Okay, it's done. All right. And now we are ready to actually run it. Okay, everyone, take a deep breath and go to exercises. Are you ready to run it? All right.
I'm sorry, Professor.
So let's go ahead.
I'm going to do the same process again that we did earlier, but run mystery first or after? Because I had to reinstall the basic dynamic analysis tools.
Oh, okay. Yeah. Basically, we need to configure our process monitor to filter out everything except mystery.exe. So yeah, basically everything is the same except we set the filter to mystery.exe.
Got it. Thank you. Sorry.
Sure. So all right, is everybody else ready? All right. So what I'm gonna do is I'm gonna have you run it and then let me know what you're seeing, and we'll talk about it. Okay. So I'll give you like 5 minutes to try that, and then we'll try it together. So go ahead. All right, folks. So let's try it together. So I'm going to go ahead and I'm going to now run mystery. Boom. Okay, it ran and it produced a lot of different kind of output. And I'm also going to take the second shot. And let's see what we're going to end up with here. So it's taking the second screenshot right now. And not screenshot, registry shot, right? Oh, it supports so many languages there. And I do compare. And let's see what we got here. All right, we really got some stuff going on here. So we can see that it says that 2 new keys have been added. Okay, so when we compare the 2 snapshots, we can see that there should be 2 keys which were not there before. There is the malware subkey and there is the malware key. It says they've been added to HK current user, that path, and malware subkey. Curious. So I wonder if it is still there. So I can run regedit and I can try navigating to that. So I'm going to go to HKey current user, HKey current user, and from there, I'm going to go to let's see, where you go? HP current user, app events. And I'm gonna look for, ooh, do you see something? Do you see something? Do you see what I see? There it is, right? It has created a key, and it's called malware subkey. There it is. Oh, but look, I can collapse it. Wait, there is more. Ooh, malware key. See the resemblance, right? So, do you see how RegShot has helped us identify the changes that were made by the malware? Yeah? See that? Seeing is believing. Yeah. So, now, can we also observe this in Procmon? So let's see what Procmon has came up with there. So we see a lot of different things. Let's see if we can find the one related to this one. And so it begins, okay, right here. So we have a function, reg create key in hkey user, and it's called malware key. Guess what reg create key does? That's right, it creates a key, right? It is exactly, it does exactly what it is named as, okay? Then we have another reg create key, which creates the malware subkey. See that? Right? Now, do you see anything else that is interesting in regards to the registry? Anybody discover anything else that is interesting? The run thingy, right? So what about the run thingy? The evil malware, right? So when we look here, I noticed something right here in Procmon. We are creating a value in the key key current user software Microsoft Windows current version run. What is this path again? Does this path remind you of something?
Very similar to the notepad that we were looking at earlier.
Yeah, and what did we do with notepad that kind of gave us problems at first?
It was a startup program.
Yeah, we wanted. Yeah, right. We wanted to make it run on startup. So it looks like this malware is calling a reg set value function, and it looks like it is trying to set a value inside of the current version run, which is where the startup entries are. And that value, as Carla has pointed out before, it's called eval value. So and what is the data that it is storing in the eval value? Oh, look, the data is evalmalware.exe, right? See that? Yeah. So that's, yep, go ahead. Mm-hmm.
I'm sorry.
Go ahead.
What does eval value represent? Is that like a space for a different key or something? Or is that just the value itself?
It's just the value itself. So, and I was about to actually go there. Actually, let's go ahead and go there. And by the way, before we go there, I also like to point out that inside the malware key, we have a value called hello malware. And if we look at RegShot to the list of values added, we'll probably see it somewhere over here. And there it is, okay? Hello malware. And it looks like this is a integer value. Its type is regdword, and it's set to 1. Okay, yep. It is set to 1. And if we look in Procmon, we will see that as well. Let's see, and there it is, okay? So it's doing a reg set value on hello malware underneath HKCU, malware subkey malware key hello malware, and it is writing the data of 1 into it. All right. So yeah. All right. Looks like I was good. Now let's go to that path in regedit. Let's go to the current version run and see if the value is still there. So I'm going to go to current user, software, Microsoft, Windows, current version, and run. And as you can see, there it is. There is the evil value. And inside of it, it has a piece of data called evil malware. And as the question asks, like basically all the values in the current version run, they store the paths or the programs to be launched on startup. So basically, this tells Windows that when it reboots to launch the program called evilmalware.exe. Now, is there actually such a program? No, I did not actually create such a program because, the point here was a registry exercise. So yeah, so basically that happens. That's what happens right here. Now we also see a bunch of other values being modified there. I can tell you they're not necessarily related to malware. You will always see those two change usually because they are related to basically random number generation in Windows. The current control set, typically this one relates to different kind of services. So my malware doesn't mess with that. So, and this is related to regedit itself. So once again, my malware has nothing to do with this. All right. So does this make sense, folks? How do you see how you have all those tools to see what changes the malware made? And then based on those changes, you can infer a lot about the malware's behavior. Okay. Make sense? Oh, and Ryan is asking, do you need to complete directory to the exe if it's isolated in the run directory? Yeah. Yep, you do. You do. Yeah. Like I said, I didn't provide the actual directory or a valid executable because I tried to subscribe to the KISS philosophy on this one. You know KISS, right? You know the KISS philosophy? Keep it simple, stupid. Yeah. So yeah. So, but don't worry. If I might not be so nice in the future, wink, wink. Okay. So now, what does this malware actually do? Well, this is what it actually does. I've written, like, this is its source code that I've written. Okay. That's what it does. So it basically opens the key. Okay. And then, so it opens a handle to the H key current users key. And then inside that key, it creates a malware subkey, malware key path. And then underneath that path, it creates a hello malware string. So basically the way in which reg create keyx works is that as an argument, it takes the handle to the key underneath which I want to create another key, okay? And then I specify the path that I want to create, and key write is necessary because I'll be writing, and then I pass in a reference to a handle to the new key that will be created. So once this function successfully creates a key, it will store the handle to that key right here. And then when I call regSetValue function expects a handle to the key underneath which you want to create the value. And then I have to specify what type of value you want to create. So here I said I want to create an integer value. And then I provide a value or a reference to the value as a parameter. Okay, so that's basically the idea. So and Carl is asking, where does the execlp? So execlp is not related to this. That's a Linux thing. And Joseph is asking, does this reg have anything to do with regex? No, completely different things. Yeah, regex is something that is used for parsing, and this And registry, is basically like registration. That's where everything is registered. Sometimes you'll hear people refer to Windows registry as the system hive, okay? Hive, hive, like the place where the bees live, okay? So that's basically the idea, right? Does this do anything malicious? Well, not really, okay? Nope. This one is not really malicious. It just messes with the registry to create activity, okay? Does this make sense? Yeah? Are we good? It's a replicator virus worm, yeah. Now, you still might be wondering, so what the hell does the previous malware which we ran do? Well, to understand it, we need to learn a little bit more, okay? So let's go ahead and let's talk about something now that is very different from the Windows registry. So let's go ahead and let's talk about that. So as we've seen when we ran the previous malware, we noticed that it was trying to connect to the network. I mean, it was trying to open up a TCP connection. Okay, so what do we do about this? How can we study the network activities of the malware? And how do we know to what domains the malware connects to? Let's say that malware inside of it has a list of domains that it should be connecting to, but we cannot see it, for example, because let's say the malware is obfuscated. So we cannot just do a string dump and hope that inside that string dump, we're going to see all of the domain strings, okay? A classical example is botnet. So a typical botnet program will try to initiate connections to one of the command and control servers to which it should be reporting. Now, if one server isn't reached, it'll try another one and another one and another one. Of course, we as malware analysts would be very interested in knowing what those domains actually are. So how do we get malware to give up its secrets? How do we get it to reveal to what domains it is actually connected to? Well, I'm glad you asked, because this is what we're going to be talking about next. It is the topic of faking the network, okay? Fooling the malware into thinking that it is connected to a real network, but in reality, we'll be spoofing a bunch of network infrastructure in order to dupe the malware into revealing its secrets. So we can intercept and monitor malware's attempts to establish TCP connections and to send DNS queries. If you took 471, you definitely know what DNS is, stands for domain name service. And domain name service is basically the service used to translate domain names to IP addresses. When you go to www.go.com, that domain name means nothing to the network. Networks don't work with domain names, they work with IP addresses. So first, your system would send out a DNS query to the DNS server and ask it to get the IP address of www.go.com. Once that happens, then your system will send a TCP connection request to that IP address, okay? And you can actually send DNS queries manually, and that works on both Windows and Linux using pretty much the same command. But if I want to know the IP address, for example, of duck.go.com, I can just use the NS lookup utility, NS lookup, www.duck.go.com, and you see, it has returned to me the IP address of duck.go.com. Okay, so whenever you visit a new domain, behind the scenes, first your system is going to send out a DNS request. Now, we can always intercept those DNS requests and spoof the IP addresses. So malware can ask, I would like to connect to the following domain where my command and control server is hosted. Well, I can intercept that request and as a response, return the IP address of my server. So I can trick malware into thinking that my server is actually the command and control server and get the malware to basically send its communications to me. So how do you do that in practice? Well, let's go through this in detail. So once again, the DNS stands for the domain name service, and its job is to translate domain name to IP addresses. Okay, so for example, if I want to go to google.com, I want to know its IP address. So DNS is a client-server architecture. So there is the DNS server, which is basically a server typically hosted by your internet provider, or if you're in school, it is the school. Okay, it's who you talk to in order to get the IP address associated with the actual domain. Okay, and the DNS server will talk to an entire hierarchy of distributed systems around the world in order to find out the IP address. Okay, you will learn a lot about the details of how that works in 471. But for now, just know that DNS server is something we contact in order to resolve a domain name to the IP address. So, and the DNS client is typically your browser, right? It's your application that is using the DNS service. So, for example, my DNS client, let it be the browser running my system, can send a DNS query saying, what is the IP address of www.google.com? And the DNS server will return back the results saying the IP address of www.google.com is 216.58.219.4. All right? So far, so good? Yeah. Now, what happens if I send a query for a domain that does not exist? Well, in that case, the DNS server is going to return a message called an X domain. So basically, an X domain means that the domain does not exist. So for example, if I do NS lookup, facebook.com, NS lookup, say www. That probably doesn't exist, .com. And indeed, this domain does not exist, and the server is basically replying back with an X domain. Okay, so that's basically the idea. Yeah, I heard that Facebook was out recently. Which caused a lot of distress because some people had to go outside for the first time. Yep, it's a DNS problem. Yep. Facebook was down for a while because of DNS. Yeah. Now, malware is just like everybody. Malware wants to access domains. Now, whenever the malware tries to access a domain, well, it needs to know the IP address of that domain, right? Just like all other programs. So, under normal circumstances, your malware will send out a DNS query saying, what is the IP of malware.evil.com? Let's say this is the command and control server that the malware uses to call home. So, and the DNS server is going to reply, this is the IP address of this domain. And malware will say, okay, great. So I'm going to now connect to this IP address, which represents my command and control server, and just start exfiltrating. Okay? That's what normally happens. But we here, we say, hey, malware, not so fast. So we can deceive malware into thinking that our server is the command and control server. How do we do that? Well, comes in the DNS spoofing. We'll be using a program called Apate DNS. What Apate DNS does is it acts like a DNS proxy. Basically, what a DNS proxy is, it will accept the DNS requests from all of the programs running on your system, and it will display them and it'll forward them to the actual DNS server. When the DNS server gets sends a reply, Apate DNS will show the reply, and it'll forward it to the program that made the request. You may say that, okay, I mean, I get it. Apate DNS is kind of like the man in the middle between the DNS requests sent by the malware. So how is this helpful? Well, did I also mention that Apate DNS can also spoof DNS replies? So when malware sends it a request, it can reply by itself with whatever it wants. Let's take a look at exactly what happens. So I can configure Apate DNS to reply to malware with for every single request with an X domain. And once again, an X domain means what again? I forgot. What does it mean? Yeah, domain not found, right? So what we're trying to do right here is to get malware to reveal all of its domains. Okay? So how can we use this technique in order to do this? Well, malwares will typically have multiple backup domains. So malware says, what is the IP address of malware.evil.com? And it sends out a DNS request. Apate DNS intercepts that request and responds with an X domain saying, sorry, it doesn't exist. Malware says, so looks like that server must either be down or, or maybe somehow the network security measures are blocking it. But I'm clever. I have another domain. So malware will try to send now a DNS request asking for the IP of its other domain. Okay, malware1.evil.com. Apate DNS can then again use this technique to say that, hey, sorry, but this is not found either. So, and guess what we accomplish by doing this? What does this accomplish? And why is this useful? What does this give us? Yeah, we get all of the domain names to which malware is programmed to connect to. Okay, make sense? So we're basically milking malware for information. We tricked it into thinking that its servers are down, and it kept asking for all the other servers. Make sense? Now, we can be even more clever than that. What will malware likely do when, let's say we're talking about a normal operation? Let's say that malware asks for the domain of malware.evil.com, and let's say the DNS server replies with a valid address. Well, typically after that, malware will open a TCP connection to this IP address, and then it will typically start sending data over that TCP connection to the server. So how can we get our hands on that information? Well, who says we have to reply with an X domain every time? Let's say that when malware asks Apate DNS, what is the IP address of malware.evil.com, instead of sending an X domain, what we can do is we can send an IP address of another server, such as, I don't know, my server. And guess what the malware is going to do then? What will it try to do? Yeah, it'll try to connect to my server, right? And to send the information to that server. You got it. Okay? And that's exactly what we're going to do. So we'll be studying Apate DNS and how it can be used. So this is what Apate DNS looks like when you run it, and we will run that in a moment. But it has a really nice window right here. And whenever you send a domain query, the requested domain is going to show up right here. And right here, it'll say found, if this is a valid domain name. Okay. Down here, it has the IP address with which to respond to every query. And then right here, you have this number, which specifies how many spoofs you should send. So this will spoof this address to the first 10 queries. Okay. So questions? Questions?
I was curious, while we were looking through mystery.exe, there was an encrypted file path in one of the registries. Why was that there?
Oh, that was probably done by something else. That was definitely not done by my program. So, yeah, some Windows program probably did this. It's typical. I do see things like this from time to time. Just random Windows stuff. Not malware. I know that. So, yep. All right. Questions? How do you know if the network is attached or not? Yeah. So in VirtualBox, you know whether the network cable is connected. You can either do it from the VM menu, or if you go to settings and you go to network, and if the enable network adapter is checked, that's one thing. And another one is, like, if you collapse advanced, it'll have cable connected. So you want to uncheck the cable connected, which will basically, it's sort of like a simulation of pulling the cable out from the VM. And you can also do it from the VM menu itself. Like if I run it and I go to devices and I go to network, you see right now there is no check next to this cable. So where would we be without that? So we would so right now it's unchecked, so it means it's not connected. And if I connect it, you'll see that a little check appears right here. Okay, so now it is connected, and now it is not. See that? So that's basically the idea. Yeah, so if your cable connected is unchecked, it means you're disconnected, which is what you want. All right. Questions? Sure, yep. And we will continue next time. Oh, by the way, folks, there is a security tag day event that is taking place this Friday. It was posted on the social networks. I think it starts at 10 a.m. if I remember correctly. It goes 10 to 2:30 on Friday. Yeah, I think it was posted everywhere, but I can definitely forward it to you. A link is going to be posted on their website, so I will send it to the entire class and I'll post it on Zoom. Yes, I'll be there as well, and I'll be speaking. I'll be talking about the advanced persistent threats. So basically, the approaches which the state actors use in order to attack systems. Yep, that's the security day. Sorry, the security awareness event. Yep. Yep. So it'll be a simplified version of the advanced persistent threats lecture. All right. And also, we're going to have a panel of speakers where people will be asking us security questions, and we will be answering them, or we'll be trying to. Yeah. All right. All right, folks. So if there are no more questions, I mean, again, the next assignment is going to be up pretty soon. And what time will we? Yeah. So we do have a question about the event. So yeah, it goes from 10 a.m. to 2:30, I believe. And according to the last email, the Zoom link will be posted on their website. I'm going to send an email advertising the event to everyone. So, and I'll post it on Discord. So, all right. Yep. Cool. All right. Paul. Yep. That's what I say. All right. All right, folks. So if there are no other questions, thank you all for dropping by. And we'll continue the discussion next week. And you can crack any malware. And as always, peace.